ice cream in a plastic cup. Finally, a 70-pound cannonball.
What is interesting and also frustrating about his invention is that he's using a combination of Tesla coil and Van de Graaff to produce a very disruptive and lifting experiments, which in one case, for example, actually lifts a 19-pound bushing toward the ceiling just from electromagnetic fields. Now, when we analyze that, we find that there's position versus time graph that we can plot, and also the velocity versus time. But when we actually analyze the acceleration versus time, it's an increasing straight line. So we're forced as scientists to admit that we have a third derivative effect, which, for my mind, actually lends itself to an anomalous new force, which I call hyperforce, because we have to take a derivative of that to finally get a flat, straight line, a constantly increasing acceleration. So the Hutchinson effect has been used as a benchmark for a comparison to many other high voltage propulsion devices. Electrogravity, in other words.
Now that we've witnessed the awesome potential of these revolutionary new energy sources, some interesting questions begin to surface. What are the consequences to the environment, to the very fabric of space-time itself, once we begin harnessing these little understood forces on a planetary scale? Remember the promise of nuclear energy, that electricity would be too cheap to meter? Are there downsides to tapping free energy that we may not be able to predict until it may be too late?
We have effects which can get down now into the very fundamental thing that drives everything, the mind stuff, the connection of the mind to the body and everything. For example, if you were to generate extreme pulses, extreme powerful pulses of this so-called scalar potential stuff with the hidden internal stuff, if you jerk that or hard enough, you jerk the normal smooth flow of time stream, and what you really do is you snap the body loose from its mind connection. You jerk the two loose from each other. That's instantaneous death at every level. Every cell dies, every germ dies, every paramecium dies, every virus dies, the whole body dies. So obviously, if you're going to try to think of energy in those enormous amounts, you're going to have to be extremely careful. You can't do that just willy-nilly without risking terrible effects from it. So there are some limitations that will emerge on this technology.
There is a danger, however, that you may tap too much zero-point energy, and then, of course, these things would heat up and explode, which has happened a few times with these devices of mine. So, in essence, it's an interesting technology to get involved in, but I notice that there's some precautions one needs to take. If you're having too much drawing from the electromagnetic jitter of zero-point energy, you're going to get a minor meltdown. And I had to clean this area out here once because of a minor meltdown.
Would a new energy source be dangerous? For example, I would say, of course, you have to respect it. I mean, it's energy, so therefore, it's always potentially dangerous. It's double-edged. And I think it would take a healthy respect to investigate it. One should be cautious, and that's very reasonable. I've heard some good things. I've heard there could be health effects. There could be good effects as well as the potential for detrimental effects. I think it's like anything else. It's energy. And it could be used for good, and it could be used for bad. It's up to us.
Perhaps because of their traditional understanding of invisible forces like chi or ki, Oriental cultures, especially the techno-enthusiastic Japanese, embrace the concept of free energy. Well-respected scientists like Shinichi Seki and Tsuhuji Inomata are receiving substantial government and industry support.
Meanwhile, the Japanese, of course, are beginning to commercially develop various systems. For example, a Japanese consortium funds the Pons and Fleshman work. The Japanese Toshiba Corporation is working with Inomata, and various other corporations are coming together to develop free energy options. And of course, Japan has no vested interest in oil. They don't have any domestic source. So it's in their best interest to be the first kid on the block to make little gizmos that will replace our circuit breakers and internal combustion engines.
To understand this machine, you need, mind change, paradigm shift in yourself. So far, physics, ordinary science, consider only material world. But we should think another world, as an unseen world. And we should recognize that unseen world and material world is connected. This energy comes from the other dimension.
We'll really have a true science when it is accepted in science, and a true technology when all the phenomenology is thoroughly worked out and thoroughly understood, when all the models are redone so that we adequately can model this theoretically and we can do engineering. We can sit down and design the circuits. They'll work every time. We'll have components on the shelf we can buy, assemble, and they work. We're not at that stage today. We are at a stage today which is the birth of the baby. We're not at the stage where it's already a teenager running around playing baseball on the baseball lot. We're at the birth of the baby, and the birth is very difficult because it's opposed by so many interests. The orthodox scientific community still very adamantly oppose it because they think that it's nonsense. They think that it's this old idea of perpetual motion in a closed system, creating energy from nothing. And that is nonsense. You can't do that. There are very strong and very powerful economic interests in the world, probably the strongest economic interest in the world, which are adamantly opposed to it. Can you see what this does to the oil-rich nations? Can you see what this will do to many things? Now, actually, what it'll do, you'll phase the oil. Petrochemical industry won't go away. You still need the oil for the materials that's in it and the chemicals, and so it'll be more and more petrochemical industry rather than keep burning and wasting the oil and putting all the pollutants in the biosphere. So many things will readjust. It's going to wrest control from a lot of the great wealthy control barons who now dominate largely the economic world, and their world is going to change. Now, what you're going to see, I would predict, and we'll see if history bears this out, when those barons really realize that this stuff is for real and it can be made to work, and with the internet and with free publishing and computers and everything, they can no longer contain the information, and it's very embarrassing to keep killing the inventors. They stopped that about 15 years ago. At some point, you're going to see an overwhelming availability of funds become available. When the funds become available, the scientists will change over into it because they go where the money goes. They're bought and paid for, simple as that. You can't do research unless you got the funds. You cut off the research grants, professor gets without a job. He leaves the university. And so science is simply bought and paid for in this country and much of the world. When the money goes, the science will go to it. Now that will put the sharp young graduate student on it finally with some funds to do the experiments and work on their doctorates and so forth. You will have a very rapid assimilation and advancement of a totally new and extended electromagnetic science at the time.